So we'll continue with the fifth problem on medium transmission line. A three-phase 200 kilometer line is delivering a load of 100 megawatt at zero point 0.8 pf lagging at 220 kV. The conductor resistance is zero point 0.1 ohms per kilometer. Reactance is 0.3 ohms per kilometer. The line charging admittance is 3 into 10 power minus 6 mho per kilometer. Calculate ABCD constants, sending end voltage, sending end power factor, percentage regulation and efficiency using nominal T model. So using nominal T model, you are supposed to calculate all these parameters. This problem is quite a different one because here he's also asking you to calculate ABCD constants. So the approach will change. Once you know ABCD, it becomes very simple. So let us see how it goes. So first we write the given data. 200 kilometers the length of the line given. Receiving end power is 100 megawatt. Receiving end power factor is 0.8. Receiving end voltage is 220 kV. Resistance is 0.1 ohms per kilometer. Reactance 0.3 ohms per kilometer. And then admittance 3 into 10 power minus 6 ohms per kilometer. Again, since it is given per kilometer, all of these values must be multiplied by length of the line, which is 200 kilometer. So as usual, first we try to find the receiving end current by the same formula that you have seen so far. So PR is known, VR is known, cos phi R is known. Remember, VR is being converted to phase value. I got the value of IR over here. So after calculating IR, I know the formulas for A, B, C and D. For a medium transmission line of T model, A equal to D is equal to 1 plus YZ by 2. I already know Y, which is 3 into 10 power minus 6 multiplied by 200. This is admittance per kilometer multiplied by total length 200 kilometer will give me effective admittance. Similarly, impedance, resistance plus reactance into J, R plus JX multiplied by the total length 200. So this will give me impedance. So 1 plus YZ will by 2 will give me A and D. And the formula for B, which we have seen in the derivation, is Z into 1 plus YZ by 4. Since I know YZ, I can calculate B. But C is equal to Y. As per the formula, I have got these values. So now, since you know ABCD parameters, directly using the formula, instead of going through the circuit, directly from the formula, you can find remaining parameters. So you know, for a standard two-port network, Vs is equal to AVR plus BIR, Is is equal to CVR plus DIR. We have calculated ABCD now. VRIR is known to us, so it becomes easy to calculate VSIS. So I have rewritten those values. VR given in the problem, IR that we have calculated, ABCD that we have calculated. Use all of them to get VS and IS. So once you get VS and IS, you can find phi S, which is angle of VS minus angle of IS, 5.05, and this is minus 24, and calculate cos phi S, that will give you the sending end power factor. Next, we'll have to calculate the regulation, for which we use Vs minus Vr by Vr into 100. Magnitude values are to be considered. So Vs magnitude you can see is 142.14. Vr magnitude is 220 into 10 cube divided by root 3. See, Vs was calculated in the previous session, that is 142.14 at so and so. This is the magnitude. So you know Vs, you know Vr, substitute, find the regulation. Next, as usual, efficiency. Receiving end power by receiving end power, that is output power by output power plus losses into 100. Since it's a T model, this is given by IR square R by 2 plus IS square R by 2. I already know IR, I have calculated IS, the magnitudes I am taking, resistance is known, and then receiving end power is known. So substitute, first find the loss, then find the efficiency. It will give you 98.15%. See, all these problems, I am giving you the formula as well as the values. You'll have to use your calculator, do the calculation and check it. So I have covered all the varieties of problems coming in medium transmission line. Even short transmission line, we have seen few problems. So that covers the variety. All you need to do is practice them properly and go through the question papers. There you will be finding the similar varieties with different numbers. So you will have to practice them. At last we come to problems on long transmission line. See, problems on long transmission line is almost, I can say, very rare case in the question paper. To be on safer side, I have taken up one problem on long transmission line. It is almost nil, you can say. Okay, coming to long transmission line, a three-phase 200 kilometer long transmission line has following parameters: resistance 0.15 ohms per kilometer, reactance 0.2 ohms per kilometer, susceptance 1.2 into 10 power minus 6 mho per kilometer. Determine sending end voltage, sending end current, percentage regulation, percentage efficiency if the line supplies a load of 20 megawatt 0.8 pf at 110 kV. So start writing the given data. Resistance given as 0.15 ohm per kilometer, reactance 0.2 ohm per kilometer, susceptance 1.2 into 10 power minus 6 mho per kilometer, line length 200 kilometer, three-phase line, PR receiving end power 20 megawatt, cos phi r receiving end power factor 0.8, receiving end voltage 110 kV. So if you remember the long transmission line, we had the final expression for Vs and Is. So I'm going to take this expression. So Vs is given by Vr cos hyperbolic function of gamma L plus Zc sin hyperbolic function gamma L IR. Is is equal to Vr into sin hyperbolic gamma L by Zc plus cos hyperbolic gamma L IR. So all you need to do is find out all these values individually, substitute and find VSIS. So first let us come to VR. VR is already given in the problem 110k. To get the phase value, I am dividing it by root 3, line value to phase value calculation. Then IR, you know already how to calculate IR by using this formula. PR is given as 20 into 10 power 6. VR is given as 110k by root 3. Cos phi r is 0.8. So by using this, here I'll be getting IR. So I got two parameters, one is VR, the other one is IR. Next I have to find characteristic impedance ZC, which is square root of Z divided by Y. So Z in this problem, impedance in this problem is 30 plus J40. So how we have got this 30 plus J40? Resistance is given as 0.15 per kilometer into 200 kilometers, that will give me 30. 0.2 is the reactance per kilometer multiplied by 200 kilometers will give me 40. So the effective impedance is 30 plus J40. Similarly, admittance was given as 1.2 into 10 power minus 6 mho per kilometer. Multiply it with 200 to get the effective admittance. Now there is a small mathematical catch over here. So you'll have to find square root of a complex number. Impedance and admittance are complex numbers. So what you'll have to do is first find out Z divided by Y. You'll be getting a complex number. So that complex number is this one. So what you have to do is square root of X at an angle theta. Whenever you're having any complex number of the form X at an angle theta, that is given by root of X at an angle theta by 2. Straight away, if you try to calculate square root of this, it will not give you any answer. It says invalid or mathematical error. So what you have to do is use this approach. So you have to take the square root of this magnitude and divide the angle by 2. This is what you have to do when you always try to find the square root of a complex number. So Z divided by Y is giving me this value. So I am going to take the square root of this magnitude, that will give me 456.43, and angle component is just divided by 2, theta by 2, minus 36.86 divided by 2, which is 18.43. So this gives me ZC. So far we have calculated VR, IR and ZC. Now I have to find out cos hyperbolic function of gamma L. Generally it is given by the expression 1 plus yz divided by 2 factorial plus yz square by 4 factorial and so on. So first I will be going only for first two terms. So I know the value of y, 1.2 into 10 power minus 6 into 200. Z is 30 plus J40. So I am going to substitute in this expression and I will be getting cos hyperbolic function of gamma L. Actually, to get the accurate value, the series, complete series is to be taken. So for simplifying the problem solving, only two values are taken here. Similarly, sine hyperbolic function of gamma L is given by root of yz plus root of yz the whole cube divided by 6, part of the series. So again, remember, whenever you are trying to find the root of a complex number, because yz when you multiply, it will give you a complex number. Root of a complex number, you should be using this. You should take the square root of the magnitude. Angle straight away theta by 2 has to be taken. So then if you solve this, you will be getting sine hyperbolic gamma L value. So now what you have to do, use all these in the main formula. Say I'll come back to the main formula, which is Vs is equal to Vr cos hyperbolic gamma L, Zc sin hyperbolic gamma L IR, Is is Vr sin hyperbolic gamma L by Zc plus cos hyperbolic gamma L IR. So far we have calculated Vr, IR, Zc, cos hyperbolic gamma L, sin hyperbolic gamma L. You just have to substitute all of them and find Vs, Is. So that is what is being done here, and these are the final values of Vs and Is. Then percentage regulation. You know percentage regulation, Vs minus Vr by Vr into 100. Take the magnitudes. Vs magnitude is 69.514. Vr is 110 into 10 cube divided by root 3. Find the regulation, it is 9.45%. And the last part is efficiency. Output power by output power plus losses into 100. And here, as per the network, 3 IR square R by 2 plus 3 IS square R by 2. PR is given as 20 into 10 power 6. Resistance in the problem is 30. Magnitude of IR and magnitude of IS is considered here. First find the losses, then use it in the formula to get the efficiency as 93.25%. So with this, I have covered all the problem varieties in module number 3, that is short line, medium line, long line. So this completes, I'm concluding module number 3. In the next video, I'll have to start with module number 5. So please go through all these problems, solve them on your own. Then if you come across any doubts, please feel free to call me and ask the doubts. Anytime you can give me a call. And also, please refer the VTU previous year's question papers. Similar problems will be there with different numbers. Try out that, you'll be getting better confidence. So in the next video, I'll begin with module number 5.